Hey there, I am going to give you an update on the motor project. It's been quite a bit of time since my last update. And that's just because I've been working on other things, plus I just wanted to get more done, so I had something substantial to tell you guys. So I have done like a major revision of the project, both the firmware plus the circuits. I was using an Atmega 328 chip before, and I've switched over to an ARM chip, an M0 Plus, because the facilities and peripherals on it are just better, so I can do more. I was running out of flash space plus not enough RAM, so now the performance of the system is just better. Okay, so let's have a look at what's up with this now. All right, so let's get this in focus. This is the main motor board now, and we're using the Atmega SAMD21, which is the same thing used on the Arduino Zero. And this is just all the decoupling caps and crystal. What's great about this now is we don't need an external FTDI breakout board to program the Moti board anymore. In fact, we can just use the USB CDC port directly to program it. This is where you connect the motor outputs, which is on the reverse side of the motor driver. Okay. These are where the breakout pins go, and we've doubled the amount that are available. So now there are, what is that, 6 times 4, 24 pins, as opposed to, there used to be 12. Here's the RS-485 chip and the terminal pins for networking motors together. So the system is more integrated and capable of doing more. The RS-485 can stretch longer distances. I think I had that on the last version anyways. Okay, so that's the main motor board. Here is the encoder. This is just a very rough 3D print of it. And what we've got is the actual encoder PCB on the back. Those are the breakout pins. And inside here is where in that little gap is where the magnetic encoder chip would be. And it detects the rotation of a magnet, which is nested inside of the spindle here. So what I can do, if I can demonstrate this, is spin that. You can't see this, but I can spin this around, and this holds the spindle in place while it's rotating, so it doesn't, pitch back and forth. It just rotates on its axis above the chip, so it gets really precise and accurate measurements. And it's nice because this is networks or is read from the main motor board over I2C. This is 12-bit resolution, so we're getting 4,096 steps from the encoder. Okay, so let's see this in action. Over here, I've got this rig set up. Here is the driver board, and there's the encoder nested inside of a servo. And on the horn of the servo, I've attached a blade from an X-Acto knife, and I fixed one statically over here. so that we can see the precision and accuracy of the motor as it spins. So I've got an Arduino program set up, which just causes this thing to rotate 360 degrees every few seconds. So let me just fire that up. Okay. There we go. Okay. So what we're seeing is that it's pretty precise. It's able to quickly find its position and come to a stop. And it looks like it's hitting the same mark bang on every time, every rotation. Well, let's have a look at the actual output and the error. And what I'm saying is, how many degrees is it off from that position? And when it comes to a stop, what we can see is it's, generally it's at most about 1/3 of a degree off from that position. And because these are in degrees. Sometimes it's even bang on. Each step, one step in 4096 is represented by 0.9. So right now it's 1 step off from the desired position. Now it's 2. There's 2. You get the idea. And that's what this looks like. So right there, that's 1 step off. That's 3 steps off. That's 1. And so on. Okay, so that's the performance of this thing. Let me just shut that down. You can see having reworked this, what I've got is, let me turn this around, do something different to look at. What I've got working, or the way that the firmware is set up right now is, we have an RTOS. It took some time to work all the different parts into an RTOS, a few different threads. And yeah, that's really nice because I can have one thread which reads sensor position, another thread which controls the motor position based on the sensor reading, and another thread which looks at networking, and another thread which looks at user commands. So the way that looks from the Arduino front end, which is the way you program this, let's have a look, is all those other threads are opaque to you. And this just looks like a normal Arduino program. There are specific API calls, but I say, okay, hey, Moti, rotate to whatever position, which is 360 degrees. So rotate to 360 degrees at a speed of 255. So then it'll do that. And in the meantime, it's just reading the sensor output. But you don't have to have anything in here which is like looking at the position and telling it to stop. That's all happening in the background. And this is just like, that's the extent of the program right there. I mean, there's some setup stuff to set up the PID, but yeah, this is it. That's the whole loop, is read the position, go to a position, and for 3 seconds, just monitor the output, and then add another 360 degrees or full rotation, and then loop again. So there's not much to it. It's very easy to program, which is nice. How much is left to do? I don't know. There's 2 major things to do. I'm still working on the PID, and also working on the networking a little bit more. I probably will spin another revision of the board I'm hoping to sell the encoder on its own as a unit first, get that up and running while I work on the main motor board a bit longer. This can be used with any servo to give it 360-degree rotation and sensing throughout the rotation. I don't know. That's what's going on. I thought I'd give you an update. If you have any thoughts or comments, let me know. Love to hear from you. And hopefully, you know, I always think it's going to take a few more months. I always say 2 months because that seems realistic. Seems just far enough that it gives me some time. But you know what? It never is done in just another couple of months. So I am not 100% sure when I'll be able to release a beta version of this, but hopefully not too long. Just please get in touch, and I'd love to communicate with you to figure out how to get this out there. Okay, thanks a lot. Bye.